Good morning, everybody. My name is Matt Mason. I'm here today to talk all about the M language, which is now its official name, by the way. No more Power Query formula language. It is now officially called M. Yeah. So I do have a deep dive talk that I usually do. There are recordings online of it from Ignite Australia. It was the last time I did it. It's a full 75-minute session. Today I decided to do a bit of a pivot on that talk. So instead of just focusing on M, I'm going to show an overview of M and sort of some of the key things, and then drill into building a custom data connector using M. And so I'll be using a mix of Visual Studio and Power BI Desktop to show you how to create a custom connector and sort of talk about the M language as I go through it. So yes, the agenda today, I will cover, just go over data connector extensibility. This is one of the things that we launched last month. We announced it at Build. Lots of people are very excited about this because it's a way for you to create new data sources for Power BI. I'll talk about the M language, and then we'll go actually demo creating a data connector from scratch, which breaks one of my personal rules about never writing code up on stage, so we'll see how this goes. My assumptions for you guys is that you're familiar with Power Query. You've seen it before. You sort of understand the concepts of connecting to data and doing the manipulation. You know that there is a language called M behind Power Query, and that you are comfortable seeing code and formula. I won't have pretty visuals. So there will be a lot of code and in Visual Studio, and if that's going to bore you, I'm sorry, but this is what we're going to do today. OK, so quickly about data connectors. Like I said, this was announced at Build last month. We announced the developer preview. We've announced that we have a full public preview in Power BI Desktop. The current build, so the June build that just came out, it's actually a preview switch that you can turn on. And what custom connectors allow you to do is create new data sources for Power BI, for Power Query. Right? So you can expose new data sources. Most commonly, what people have been doing, what we've seen this used most for, is connecting to REST APIs or SaaS services, right? Basically providing a nicer interface than making a raw web request and getting back JSON and having to manipulate it. What a custom connector allows you to do is present a nice navigation table over the source, format the JSON response or XML response in a way that makes sense to the end users, apply schema and formatting and do all that stuff automatically within a custom connector. Custom connectors are actually written in M. So it's just like using Power Query. You can think of a custom connector as a set of saved queries almost for doing manipulation. Okay. Another reason people have been using custom connectors is to implement custom auth flows. That's one of the challenging things to do today in Power BI or in Power Query. Different websites will use OAuth 2. They call it a standard, but really every site does OAuth slightly differently. And what this model allows you to do is implement those flows within M. Using it as a building block for Power BI apps and content packs. My colleague Yusuf has a session right after this that will go into creating content packs and focus on ISVs creating public content packs. And typically, most of these sites and services require a custom connector to do the custom auth and formatting and things like that. And finally, this is more of an advanced scenario that I won't be covering today, but you can use an M connector to wrap an ODBC driver to enable direct query capabilities. I don't know if you guys saw the Zoom data demo yesterday, but this is exactly what they did. We've been working with them on that, where they basically have an ODBC driver. We have an M wrapper on top to customize the behavior of the driver, set different capability flags that can't be set automatically as part of ODBC, and basically enable direct query for Power BI. Oh, that's a lot of things you can do with a data connector. So roughly how it works. You have a data source that you want to connect to in Power BI, and the built-in functionality, the built-in base functions maybe don't provide the best experience for you. So you use a combination of Visual Studio. We have a new Power Query SDK, which is an add-in for Visual Studio 2015-2017. You can download from the store. From the VS Marketplace, and use a combination of VS and Power BI Desktop to iterate and author this extension. And this is basically the demo that I'm going to show today. Out of that, you get an M extension, so this file. And that file can contain your logic, your M queries, icons, branding, strings. So basically, lets you create this branded experience and branded connector. You then install it into Power BI Desktop. It automatically shows up in the Get Data dialog like any other connector, and then other people can consume it. And that's pretty much how it works and what I'll be showing today. So one of the core reasons why we did this whole M extensibility thing was that we'd like to leverage common data APIs as much as possible, right? So if you have a full-featured data API like OData, for example, your connector becomes really simple. It's just a couple of lines of code and then icons and branding. You basically point to your OData service, and we automatically get things like the schema and the navigation table and query folding and all that stuff. You get that all for free by being based on the M language. Another wrapper approach is over an ODBC driver. Same, we can ask an ODBC driver, what are your capabilities? What's your SQL syntax? And all the different things we can automatically determine from the driver. So at the M level, we know what SQL to generate and pass down to the underlying data source, right? And then the M wrapper on top lets you do additional customization of the SQL that gets generated and things like that. And finally, you can create a pure M extension. So this is what's commonly done for SaaS services or REST services. You're basically using built-in M functions like web.contents to make the web requests, and then JSON.document to parse the JSON into a structure, and then format it as a table and return it, right? And one of the things I love about M and the extensibility mechanism that we have is that it gets incrementally more feature-rich. I don't want to say difficult. It gets more feature-rich as you go. So you can create a really simple connector that just connects to a site, returns it as JSON, but you can incrementally add more capabilities, like a navigation table, like passing down parameters and filters. In Query Editor, if somebody says, filter on country, your extension can get that context and figure out how to pass that country context and the country filter down to the backend data source. Connectors don't necessarily need this, so it's very easy to get started, and you can incrementally add these more advanced features as you go. Right? And so you see samples and documentation. We're still working on getting the full range of documentation out, but at least in theory, you should be able to create an M connector that does full direct query capabilities over a backend data source. Being able to handle all the different types of transformations that are possible in analysis services and in Power Query, and be able to pass that back down to underlying data sources with custom query languages. So it's a very powerful model, but yet simple to get started with. Right, so we're in preview today. By the time we hit general availability, we're hoping to have the following things. Integration with the Office Store, sort of like what custom visuals have done with Power BI. Today, the story is you have your M extension, and you email it or send it to somebody, and they just manually copy it into a certain folder, and it will load. In the future, we'd like full integration with the Office Store. So developers can share their extension in the Office Store, and you can just search and acquire directly through there. Today, the extensions only work in Power BI Desktop, but we're working to enable it across all Power Query experiences like Excel 2016, SSDT for analysis service tabular, and all the other places that Power Query will eventually show up. Power Query is taking over the world. We have support for the gateway. So today, it only works in the desktop. Definitely need to enable extensions at the gateway so you can do full scheduled refresh and direct query. And then better development experiences in general. So versioning and dependencies. Ultimately, what we'd like is if you open up a Power BI file, a PBIX file, it says, hey, this uses a custom connector. Would you like to download it from the store? And we'll automatically go and download that, as well as any dependencies that it might need. So automatic tracking. Same at the gateway. You go to refresh something, and the gateway will automatically download all the extensions it needs from the Office Store. Make sense? Great, so let's go over the M language really fast, and then I will go into my demo. So at a high level, design tenets for M, I like including this. Basically, M's been around since about 2006, and it's been iterated on and changed over time. The current incarnation of M was really meant to power the Power Query experience in Excel. And so to suit that audience, they made M a functional language based on formulas. It's easy to write, easy to read. There's not much syntax involved. It's basically a formula language, right? It's really targeted at the advanced, intermediate to advanced Excel users. And they kept a lot of the concepts the same between Excel formulas and DAX and M, but just different enough to make all audiences unhappy. Like 0 indexing rather than 1 indexes, and case sensitivity and things like that. But anyways, we are where we are, and I like M the way it is. So general language flow for M. Evaluation flows from one step to the next, except for when it doesn't. And so the results of the previous step are typically used in the next step. So I call this out because this is the way that Power Query will generate M, right? Hopefully you can see that. But basically, you have that first line. You're connecting to a web page, parsing it with, you're connecting to a web page with web.contents. You parse the results with web.page. That turns it into a table with all the tables on the web page. I index into that table to pull back a specific table and store that as the web table variable. And then finally, I pass web table into a function called table.rename columns, which is going to rename column 1 to rank and column 2 to 2013. Right? So you see this flow from one step to another, and that matches the way the Power Query experience works, where I do incremental step-by-step transformation, and I can drill back through and see all the different steps. Now, although Power Query generates things this way, when you're writing M by hand, you're not limited to the step-by-step thing. So for example, in this bottom thing, the first line I'm connecting to a SQL database, storing that as source variable. And then I use that source variable 3 different times to pull out 3 different tables from that database. I pull product category, subcategory, and then customer, and store them in other variables. And then on my last line, I do a nested join, joining subcategory and category on category key and returning that as joined. So you notice that dim customer is never actually referenced. And that means that line will never actually be evaluated. So M is lazily evaluated, right? So I say it flows from step to step, but it's actually the opposite. It pulls on data. So when it's looking at this evaluation plan, it will look at joined. And to get joined, I need to join these 2 tables. And so it will evaluate those things. It sort of goes backwards, kind of like a T-SQL query plan, right? But if there's an item that is never evaluated or never looked at, it just gets stripped out and never actually run. This can be interesting when you are doing M extension development, because if you do things like logging, for example, and you have a logging line, and you're not actually using that logging variable that's being logged, then it never actually gets emitted. And it took me actually a while to figure that out. M types. M tries to keep a very simple type system. There's a small number of types. You'll notice that, for example, there's a number type. There's no int32, big int, double float. It's just at the primitive level, there's only a single number type, right? So all the types you'd expect, as well as complex types. So M natively supports the concepts of records, lists, tables, and functions as types and values that can be passed around. So examples here are setting types on function parameters, which is something you do very often when you're writing a custom extension. So I have my first line there, server as text. So I'm saying that that parameter value has to be text. M engine doesn't do runtime type checking, except for on parameter calls and some other cases. So there's also a concept of ascribed types, and I have this blurb of text at the top here from the M language spec. But basically, you could think of an ascribed type as a format, right? Underneath, the M engine only understands primitive types, but you can say this number is actually an int64 type, right? Now, for the M engine's point of view, it still thinks it's a number, it doesn't care. But for things on the outside, like analysis services, like Power BI Desktop, it can ask the number, oh, are you actually an int64? And it might make a decision accordingly, right? So in Power BI Desktop, in the data model, it will store columns differently based on their types. So yeah, there's this concept of ascribed types, which still kind of hurts my head when I think about it. But yeah, think of it as a number format. OK, examples of simple values in M. The most interesting things here would be the constructors. So the hashtag date, hashtag time, and date time. These are simple constructors to create these types. Symbolic operators, so all the operators that you'd expect, but there's a couple of things I want to call out. Concatenation is interesting. So in M, you can concatenate values with the ampersand. Other languages, it's plus. Here it's ampersand. And you can concatenate text and text, lists and lists, records and records, tables and tables, and date and time. Those are the only combinations that you can combine. If you try to concatenate a date and a number, you will get a cannot convert number to text error. You have to wrap it with a number to text function. I'm sure I see lots of people nodding heads. You might have hit that in Power Query before. Other interesting things are field access. I don't think Power Query ever generates this syntax, but basically if you're accessing a field of a record and you include a question mark, without the question mark, if the field doesn't exist, you get an error thrown. If there is a question mark, it will return null instead. So this is basically conditional access. Same things for when you're doing lookups and lists and tables. That works the same way. Let's talk quickly about the structure of the complex values and types. That's scary. OK. Complex values and types. So lists are with curly braces, right? So you define a list and put a bunch of items inside of it. Lists can be typed, or they can be just typed to any by default, so you can have any data type inside of it. Records have square brackets. This is the exact opposite of JSON, which uses the opposites. Again, we tried to make people unhappy with this language syntax. But yes, M records have square brackets, and the format is you define a field and then a value. And again, this has a record with name field, children field, which is actually a list, and then a happy field, which is a logical value, true. And then tables. You can actually define tables with the hashtag table constructor. The format of defining the table is the first parameter is a list of text fields that become the column names. And then you have a list of lists inside, with each list being the row values, right? So that's what it comes down to. Some other syntax for complex values. You can have functions. Functions are a type and a value, so you can actually pass functions around as a parameter. You can declare new types, for example, if you're typing a table or assigning types to a table. And there's actually binary. There's a whole binary library, and you can parse raw binary files. The demo that I used to do was parsing header information out of a PNG file. I've seen some very interesting demos or scripts show up in the wild about parsing zip files or XLSX files. There's some very interesting things out there. Lots of clever people out there who are doing things with binary. One of the core concepts in M, and I find very important when you're writing a custom extension, is thinking in tables. Everything is a table, and you always have to keep this visual mental model of the data that you're connecting to and how you want to manipulate it. And I'll show that when I'm writing the extension. But I just wanted to show a couple of slides about what a table actually is and how all the types sort of fit together. Right, so the M at the top here, this is something that Power Query would generate. In this case, I have a file.contents. File.contents is my data source function. It's going to access a file. It's going to load the sales.xlsx file and return it as a binary, which is going to be parsed by the excel.workbook function. Excel.workbook is going to take a look at that binary, parse it as an Excel file, and return a table that contains where each table of tables, so a navigation table, and each subtable is going to be a sheet on the Excel from the Excel workbook. I save that to source, and in source, I'm then iterating in. This is basically a search, a lookup, where I'm saying from that source from the navigation table, find me the row where item is equal to orders and kind is equal to sheet, and then I want to access the data field from that row, and I store that as my table. And finally, I return my table, which is the view down below. That's basically how the M functions work. So what is a table? If you look at a table, a single column in the table is a list. Right? So if you refer to the myTable.product key, you basically get a list of all the values in that column. A row, an individual row, is a record in the table. So if I index in to pull the third row, right, we're 0 index based, if I pull the third row from the table, I get back the following record. And a table is a list of records, right? So the table is basically a record for every row of the table. Last M concept I want to talk about, this took me a while to wrap my head around too, because this is one of the only places where we have the special syntactic sugar for the each expression. You'll see this in Power Query often. So a lot of library functions in M take a single parameter. So for example, the table.selectRows function, right? What it does is it will go through all the rows of your table and then select the rows that meet the criteria that's specified by this function. So what this is saying is basically is passing the table as my variable. R is going to be my row, and row goes into a function that checks where the manager field is equal to the buddy field. And then if that's true, it will select that row. So what they've added is this special syntactic thing called each, which basically replaces that R goes into syntax, right? And then you have underscore to represent that parameter that was passed in, so in this case, the row. And then finally, for conciseness and to make it closer to the DAX syntax, you can actually omit the underscore. It's sort of implied. So when you do each manager equals to buddy, that means for the current row, compare manager equal to buddy. So all three of these statements are equivalent. They're the exact same expression. They evaluate to the same thing, just different ways of writing it. You usually don't have to use the underscore, but you might have to when you're writing custom code because, for example, if you want to call another function and pass that row value in, you'd use the underscore to pass that through. Okay? So that's pretty much the only complicated part of M. I'll go into my demo. I was really happy about this demo. So this demo is about connecting to a web API, common thing. The demo I decided to do is I have a big problem where I have so many games on Steam, PC games, and most of them I haven't actually played yet. And ultimately what I wanted to do was do cross lookup so that I could see the ratings of the games, sort by games I haven't played yet and highest rating so I know what game to play next, right? So, very important problem. I was happy with the demo until I sat down with people yesterday who are doing AIDS research to identify children that are HIV positive and need medication. And they needed a custom connector, and it made me feel very superficial and shallow. So I spent the day working with them on that custom connector. OK, so this is my demo. Like I said, I usually have a personal rule where I don't write code on stage. So we'll see how this goes. Actually, before that, let me talk about how I set up this demo. So Steam is a platform for PC gaming. They have a web API, a REST API that you can call. There's a specific method that I saw that called getOwnedGames that will give me back my list of games that I've purchased. Basically, the process I went through to connect to this API is the same that you'll go through. I find the API online. I read a bit about the docs. I check out, OK, what's the authentication? In this case, I just have to pass in an API key as part of the query string. I read about the return values and the formats, and then what I need to do. So basically what I had to do was go to the Steam site, sign up for an API key, a developer account. So now I have my own developer key. I know to call these methods, I first have to get what's called my Steam ID. I have a profile name. I need to do a lookup to get the ID that they use internally. And then I'm going to call that getOwnedGames function to get all my games. And then I have to process the JSON results. If I were to extend this demo, I could do the lookup of ratings and things like that. I won't have time to cover that today, but I have a post. All this code is up on GitHub if you're interested in checking it out for yourself. So let's go over to this. So like I said, the first thing I have to do, API-wise, is I'm going to have to look up this Steam ID. Before that, when I set up my machine, there is a GitHub site, Microsoft Data Connectors GitHub repo, which has all of our documentation on how to get started with data connectors. You can check that out. In Visual Studio, I downloaded this Power Query SDK, which adds M syntax highlighting and IntelliSense, autocomplete compilation, everything like that to Visual Studio, which is what I'm going to use to actually develop my extension. So here I'm in Visual Studio 2017. I'm going to create a new project. You see that I've installed the Power Query SDK. I have an option to create a data connector project. This is going to give me a skeleton data connector. Okay, that's able to connect to a data source. Let's call this Steam. It's going to give me, if I look at my project, Doesn't let me zoom over there. OK. If I look at my project, it's going to give me two .pq files. One is going to be my extension, which is basically I'm going to turn into my data source. And then the other is a test file that I can run in Visual Studio to test out my code. So I don't have to always go to Power BI Desktop. So let me make this. Hopefully you guys can see that. Great. So the default template that it gave me, it's basically a hello world. If I ran this, it would just give me a simple message. I'm going to make some minor changes. This is basically declaring my data source, a new data source called Steam. I'm saying authentication is explicit because for Steam, it's, I can access as anonymous. I just have to pass in the API key. So I'm going to leave it as anonymous. I could pass in my profile ID as an argument, which would send a prompt up for me. But for now, I'm just going to hard code what my profile is. Zealot is my gamer name. And that will be fine. And so if I just say source is equal to profile, extra semicolons, source. OK, so people who know M are from Power Query. I'll call it a couple of things. Within Power Query, where you're authoring is an expression. OK, so it starts with a let and ends with an in. An in can be thought of as a return statement. So an in is actually an out, which is great. You'll notice semicolons. There are no semicolons in Power Query. It's because the format of this document is called a section document. And a section document has a bunch of statements. It doesn't have to be, each of those statements is an expression. So it's formatted slightly differently. But that's pretty much the only difference. And then I have this keyword called shared. And what shared does is it marks that function as something that should be exported. Right, so then that's how the Power Query engine knows which of those functions in the file it's able to access and able to call and able to expose. Okay? So basically what I've done here is I've exposed a function called steam.contents. I've associated it with my data source kind called Steam. And then the publish thing is basically the information it needs to register in the get data dialog. So if I run this in Visual Studio, first time I run it, I get prompted for credentials, right? Just like you would be in Power BI Desktop. I say anonymous, set credential, and run. And now I get back my boring value. I just return my profile name, but at least I know that it's working. Great. So let's go back to the things I had to do. First thing I need to do is there's this URL that has a profile name in it, and I need to extract this value, right? Common things that you'd need to do in M or in Power Query. In this case, I'm just going to write it. So let's call this get profile ID, or sorry, get Steam ID equals, and I'll pass in the profile as text. And I will say source is equal to web.contents. And I'm going to pass in the string. In this case, I will just concatenate the string. And then return the value. Whoops. In source. And I know this is returning an XML document, so I'm just going to call the XML tables function over that to parse it. OK. So now when I run, I need to update my actual function to call it. That helps. Whoops. So get Steam ID, pass in profile. So now when I run it, I get a table of that XML all parsed for me. So this is a table, so what I'm going to want to do is iterate into that first row and then grab that Steam ID value. That's what I'm going to need. So let's do that. So I will say first row is equal to table.first. Oh, I can actually do first value. I forgot I could do that. Well, that's exactly what I want. Source. Isn't IntelliSense And syntax highlighting, wonderful. Yes. Great, and now I have the value that I want. Okay, so that's going to be my Steam ID. Okay, next up, looking at the Steam developer API, this is the call that I want to make. It shows an example URL and all the parameters that I can pass in. I have a little cheat sheet here because there's a couple of things that I need. One, I have to pass in my API key. I'm going to pass in the Steam ID, which I already have. Next, I want to get my API key. So I have this helper function. Now, I could hard code in my Steam ID, or I could hard code in my API key into my file, and that's definitely a valid way of doing it. But instead, what I'm going to do to make this more reusable is I have this API key file. All this is a text file with my actual API key. And because this is being recorded, I won't show it on screen. Otherwise, I'd have to regenerate my API keys. And then I have this helper function here that's going to call this special method called extension.contents. And what extension.contents lets you do is load files from your extension. So basically, when I build this extension, it's going to create a .mez file or mez file. And that mez file is essentially just a zip with all the contents of my project inside of it. Right? So I can load any of those files as a binary. What I do is I load it and then convert it to text. So that will give me my API key. Only thing I need to do is set the build action of that to compile so that it gets included inside of my mez file. And then I'll call it. So API key is equal to load from resource and pass in the name of my file, API key. Great. So now I have my API key, and what else do I need? I want to call this. So let's create a new function. Let's call it getOwnGames. And I will pass in my Steam ID as text. Now this is the format that I'm going to want. So say source is equal to web.contents. Actually, I'll just paste this in. There's a bunch of parameters here. Now, rather than hard coding in the string, what web.contents lets me do is actually create a query record. So I'm going to create a record with each of the individual parameters. So first I need key, and key is equal to API key. And next up I need Steam ID. Steam ID is equal to Steam ID. And then what are my other parameters? I have format and include app info. So format is going to be equal to JSON. And then include app info is equal to 1. Everything has to be a string, though, for this. And then I can pass in query as a parameter here. Again, if I forget, I can hover over. Oh, it doesn't show. I can hover over and see the IntelliSense and the tips and things like that with the function arguments. The result of this is going to be a JSON document. So let's just do JSON document like that. In source, let's run this. And again, I get the same value because I didn't actually update my function to call it. So here's this, and I'll say games is equal to getOwnedGames, and pass in my source. Should make this more clear. Let's call this Steam ID. Steam ID. Great. Now when I run this, I get back a JSON record. Now, I could manually type the M to expand and do stuff, but that's not fun and that's hard. So instead, what I'm going to do is copy this over to Power BI Desktop to actually manipulate the data. Now that I can actually get data from my source in a raw form, I'm going to use Power BI Desktop and the Power Query experience to format that data into a shape that I want, and then I'll copy that code back into my extension. So I actually have this handy utility here called auto deploy, and that's going to copy the output of my build, my steam.mes file, into my custom connectors directory. So that when I build, my file shows up here. And when I launch Power BI Desktop, it should automatically show up in the Get Data experience, unless I did something wrong. But hopefully it works. Great. Do more. I type Steam, and it shows up. Connect. I didn't have any parameters on my function, so I didn't get prompted. If I had asked for Steam, my profile ID, for example, it would have shown a profile prompt or a prompt to enter that value. I get my credential prompts here. First time I'm connecting, I say yes, connect as anonymous. And now I have the standard Power Query. So I have my JSON response. I want to drill into the record. I want that list of games. This gives me a list of records. I convert to a table. Expand this. Now I have my data. Let's set data types to make it nice and formatted. So my name, these icon URLs, will do something with that later. From the documentation, it basically says it gives you this GUID value that you have to use to figure out what the URL is. Why they don't return the URL, I don't know. But and then finally, the last one is a true false or logical value. I also see that this API returns null for false, which is a bit weird. So I'm just going to do a replace values. Again, all standard stuff you do in Power Query, right? There's something else I saw here. Some of these values have special characters in it, like trademark symbols and stuff, and I'm worried that's going to mess up my report or my other formatting, so I'm just going to replace them with blanks. So it's going to go through, and I think I saw another one down here with, yeah, that's the one, Far Cry. Replace values, and I'm going to replace this symbol as well. Okay. So I have a set of transformations. I'm pretty happy with this shape. I could do other things like making nicer column names and stuff, but for now, I think I'm happy with that. What I'm going to do is open up the advanced editor. Never mind the syntax hide thing is coming any day now, I'm sure. Ask Miguel about that. And now that I have the transformation code, I'm going to go back to here and add the rest of my code. So let's see. So I just have to fix that up. I've pasted that in. Great. So if I run this now in Visual Studio, now I have this nicely formatted table of data. And yeah, I'd be happy with that connector. But since I do have some time, let's show some more advanced stuff and show off some more AM stuff. So I said those, go back to here to take a look. There's these icon URL and logo URL things that are these values. I'm looking at the docs. I know I have to prepend a full URL and then append .jpg to actually make the URL. And I could go in to here and do an add custom column and do the calculations. It's always easier doing things through the Power Query experience rather than an M. But I like a challenge, so I'm going to just write it by hand. Let's just call this replace so I can type it easier. And what I'm going to do is call, let's do logo first, table.add column, pass in the previous table. This is going to be logo URL. And then I have to pass in a column generator function. Now I have a helper that is going to take that base image URL that is in the documentation and do all the appending that I need based on the app ID for that game. And just add this function in here. And what I want to do is, so for each row of my table, I'm going to call the make image URL and pass in app ID, which is one of my columns. And then I have to pass in this is logo, right? img logo URL. And if I look above, I can see that's the one there. Just make sure I have the right one. And I'm missing a brace. And this is going to be URI.type. Setting the type, and then return logo. Just make sure that worked. And if I scroll over, I see, OK, great, I have the logo URL. And while I'm here, I may as well add icon. Call this icon. Call this icon. Return icon. And then replace this with icon. Great, so I think I'm OK. So now I've updated my connector. So what I need to do is I'm going to close Power BI Desktop, rebuild. My thing automatically copies the new MES file over. Let's run this, and we'll make sure the image URLs are working and everything like that. So let's connect again. Remembered that I had credentials last time, so it just goes through. Let's just load it directly. The only thing I need to do in the data model is flag that, well, one, I don't need these values anymore, so let's hide and hide. And then I want to flag that these URLs are, oops. Oh, actually, yeah, I made a mistake. I added the same column name twice, so it just overwrote it. But anyways, I'll just go with the one here. I have my web URL for icon. And I'll go back to my reports. And so now I can drag on this and playtime and URL and the icon. Whoops, did that not? Did I not set that right? Oh, that's right, image URL. And now I have images. So I can create a very useful report to identify which games I haven't played. My boss is in the audience. I'm not going to show how much my play time actually is for some of these games. OK. Any questions on that before I jump back to the slides? No? Yep.
Is that auto-deploy part of the Power Query SDK?
No, so the auto-deploy is an additional extension. I actually linked to it as part of the Getting Started documentation because I found it was very useful. It's a third-party extension on the VS Marketplace. But yeah, it's very, very handy. Call out if you've tried out the custom connector stuff in the May build. The instructions are a bit different in June. May, you have to set an environment variable and things like that. In June, you no longer have to do that. And so all the steps will be on the GitHub site. Question back there? No?
So the query structure that you have,
Yep.
will that work better in each statement? Because I've had issues trying to concatenate the string before, where it does not with fails in service.
So the question is about concatenating and building dynamic URLs and it failing in the service, meaning the gateway can't do it. Yes, we're working on improving that. So basically, so the gateway can refresh the same set of queries that you can write in Power BI Desktop. But one of the advantages of using the custom connector model, so the reason why it fails in the gateway is because the static analysis that we do on the query can't determine what URL you're actually accessing because it's built dynamically. When you create a custom connector, anything you do inside of the connector doesn't really matter. It's completely hidden and isolated to the connector. From the gateway's point of view, all you're accessing is Steam. So you can do any sort of URL combination and dynamic manipulation of the URLs within the connector. From the outside, it just looks like Steam. So custom connectors are actually a way to do this sort of dynamic building in a gateway-friendly way when the gateway actually supports extensions. OK, great. So let's switch back. I'll cover the last of my remaining slides, which I think is just a summary and some links. And then I'll open up to questions. So yes, the summary or the demo that I showed is creating data connectors with the Power Query SDK. You don't actually need the SDK. You could just manually create these files, put them into a zip, rename it to .muz, and it works. But doing everything through the SDK does make it a lot easier, as we showed. Custom connectors are written in M, and they're based on base M functions. If you're interested in the technical reasons why we decided to take this route, I'm more than happy to talk about that. But I think this model will create a lot of flexibility in terms of being able to deploy to the Office store, to our services, basically making things work end-to-end for end users. Today, you switch back and forth between Visual Studio and Power BI Desktop to do the Power Query experience. Now that we actually have a Power Query experience in Visual Studio as part of Analysis Services, you can imagine that eventually the Power Query SDK will have Power Query UI built into it. So there's no switching back and forth. You can just do everything within your development environment, which is actually one of the main reasons why we decided to do an extension for the full version of Power BI Desktop, full version of Visual Studio rather than VS Code or some web-based experience. As I said, custom connectors today are only supported in Power BI Desktop. But we are working on enabling it across all Power Query experiences and the gateway over the next few months. OK. So some links for the things I showed today. We have the GitHub repo that has all of our samples and getting started documentation and the technical documentation for the whole extensibility model. That's under AKMS Data Connectors. There's the Power Query SDK. You can find it from the VS Marketplace when you go to extensions from within Visual Studio, or you can download it directly from this website. I have my own GitHub site or GitHub repo for Power Query samples. The Steam connector that I just created, the full version, is there. It actually does lookup for scores by doing screen scraping on another site. You can go. I didn't want to show that on a video. You can go take a look at the code there. There's a couple of different ways that you can do it. The deep dive video that I mentioned earlier, if you look for the power of Power Query at the Ignite from Ignite 2017, Ignite Australia, there's a full, deeper talk about those M slides that I went over. And finally, we're putting up a step-by-step tutorial based on the Trippin OData service for creating custom connectors. And this basically takes that step-by-step approach where you create a very simple connector at first for OData, convert it to a REST-based connector, and then you add a navigation table, and then you keep incrementally adding more capabilities to it. So those are helpful links. REST, remember to submit evaluations. Here's some other talks at the conference. Up next, if you want to find out more about creating content packs, or you're an ISV, you have a web service, you want to create a global Power BI app or content pack for Power BI, there's a session coming up next. And other great Power Query sessions, and then that's it. I'll open it up to questions. I'll also be in the Ask the Experts booth starting at 1 o'clock until the rest of the afternoon. So you're welcome to come by and talk with me there. That's it.